nobody values the soil. No landscape conservation, anybody, forest manager, whoever, is valuing the stuff that the plants grow in. And it's just completely, because soil is dirt, muck, right? Get rid of it. I don't want to be
I think that's one of the reasons why I love it, though, is, think about everything that you love about a forest, the beautiful trees, the beautiful plants, the animals that live there. What would it look like if you took away the soil?
Welcome to the UNBC Forestry Club Podcast. This podcast is recorded at the C4 radio station on campus from the traditional unceded territory of Lheidli-T'enneh. You're probably listening from other places in BC or Canada or maybe around the world. We encourage you to recognize the traditional territory you get to learn, play, and live on. All right, welcome back to the UNBC Forestry Club Podcast. I'm your host, Hunda. We have a very special episode prepared for you today because our guest needs no introduction to those who are taking the science degrees at UNBC. He's assistant professor, a biologist who currently focuses research on how microbial communities respond to human-induced environmental changes. He also has an impressive background in studying soil carbon cycle in a variety of aquatic and terrestrial ecosystem. Oh my goodness. I was very fortunate to have him as my professor for my Biology 103, the introductory biology. His exam are some of the hardest exam I've ever written, but he's one of my very favorite professors at UNBC. And this man sitting across me on the table is nobody else but the one and only Dr. Michael Preston.
Well,
welcome
thank you
to the
very
podcast.
much for that introduction.
Yeah, thank you. Thank you for coming. I know it's really busy right now, and appreciate for taking the time to come and talk to us.
You're more than welcome.
And one dumb questions I ask for all the professors that come and talk to us is, you know how we normally just call you Michael or something, you know, walking by, but since this is a podcast, do you want us to call you Dr. Preston, or is
no, Michael's okay.
Michael's okay.
Yeah.
I just want to make sure, and I always feel bad to call people's first name. I just want to make sure. And then this episode is also special because sitting beside me is Erica Crete. She's one of our own undergrad students, or was undergrad student. She just finished her undergrad thesis defense. What was her topic again?
Ericoid mycorrhizae, soil science, ecological restoration, bit of a hybrid of all things.
That sounds so cool. And I wasn't there, but I heard some comments that your thesis defense is better than some of the PhD defenses. So
it was on
I'm not
point.
sure who you
heard
that from, but thank you.
Yeah, so it must be really good. So congratulations on the achievements, and
thank you.
Congratulations for finishing up the program. It must be a grind. So I'm glad Erica's here because I really, this episode is about carbon, about forest soils and carbon, and then to be honest, I don't know a lot about soil carbon. And so I'm just glad that we have Erica here to kind of ask the smart questions, and then I'll be the one that kind of bridging the gap. We were talking about this beforehand. Just picture I'm the one of those, a random person you met at Tim Horton at the corner store or whatever, and then I know nothing about soil carbon, but I'm really passionate about it. So I might ask some dumb questions.
No such thing.
So
just take that out of your vocabulary right now. Right? They're just questions.
Yeah. And, in forestry, we always talk about like how we should balance this and balance that. It's a balancing act. And I've found it's really fancy and sounds really smart to say that, but it's extremely difficult to achieve because balancing means it's check, balance, and compromise. It requires somebody, all the values to lose something and to compromise. And it's just not an easy thing to do. And carbon, obviously, it's a significant, it's a very important topic that the foresters have to think about when they manage their forest. So I just want to cover that topic this episode. So we know climate is changing, even though some people still refuse to believe that, which kind of blows my mind. But regardless, like it or not, we're paying the carbon tax or carbon rebates, or their carbon offset project in the province in forestry. And I also think it's just important for us as a forestry student to understand how this carbon cycle works and how our forest management can impact those cycles and how we can manage our forest better in terms of carbon. So that's what I want to talk about. So maybe the ultimate question that I want to understand at the end of this episode is how us as a foresters or as a forestry communities, we can manage our forest better for carbon.
That's a huge question.
I understand.
Right.
So I don't know if there's any angle you want to attack or anything. Break it down, Jay.
Let's start at the beginning.
Yeah.
Right. So you're saying, we're paying the carbon tax, and you're meaning that literally we're paying the carbon tax, right?
Yeah.
I'm not going to talk about politics or rebates or anything like that.
No.
But we are all paying the price for pollution.
Yeah.
Right now. It doesn't matter what your political stance is. Think about normal just waste. How much waste we generate as a society. Where does that waste go? It goes to landfill. And so it's this idea that we can just keep wasting resources, throw them away. It's just going to be somebody else's problem and not impact us. Well, that's the problem with CO2, because that's global. So it doesn't matter just what we do here in British Columbia. It's what happens in China, India, Africa, Australia, everywhere, right? The whole world. And this is why it's, we get these COP conferences coming all the time. We're going to do this, we're going to do that. And everybody kind of says a lot of stuff, which is going back to your point. We're saying we're going to meet carbon targets. What does it mean? Why do we care?
Yeah.
No, like the people who are denying climate change, these are not land managers. People in agriculture, people in forestry, they've seen the climate changing.
Oh, yeah.
Especially like producers, past 50 years, that climate's changed. Biodiversity's gone down. It's harder to grow crops. It's harder to do everything. And ultimately, that's forestry, right? Forestry is growing crops. It's just trees on a much longer time scale. So we know that is happening. And we can think of it purely through carbon credits, make climate change go away. But what's the benefits of carbon, right? No one really thinks about that.
No.
So my philosophy is it's a 2-for-1, because you're taking carbon dioxide out of the air if you manage your ecosystems properly, which is great, but you're also improving soil health. And by putting the carbon back in, that means you're going to get a more productive ecosystem going forward. And go back to the agriculture or forestry as viewed through a lens of agriculture, that's what we want to do. We want to maximize our productivity to get our best yield. Well, if you've got poor soils, you're not going to do that, right?
Right.
So that's one of the problems that we have when people start thinking about climate, because they're just thinking, it's just the climate thing, and becomes very politicized.
Yeah.
Well, let's take that out of the equation. Let's just talk about soil health. And you get climate change action while getting soil health.
Right.
But let's address the elephant in the room right now.
Yeah.
Doesn't matter what forestry does. 9.6 billion tons of carbon are released every single year from fossil fuel emissions. That is just astronomical from the land use sector perspective. So from land use, we can actually get 3 billion tons of carbon taken out of the atmosphere and back into vegetation. But we are just releasing, as a society, 9.6 every single year from fossil fuels. So
that's global.
That's global emissions averaged over the past 10 years. They're 2023 data. So for the past 10 years,
wow,
it's 9.6. So it doesn't matter what anybody does, how forestry changes its practice, how agriculture changes its practice, how anybody manages it, until we stop releasing fossil fuels at that magnitude. So, let's put it in perspective.
Okay, got it. Then, there are different talks about in forestry that it's either a carbon sink or a carbon source. And then there's another term, carbon sponge. So sometimes it's a sink, sometimes it's a sponge or source. And I don't know, so when you doing on your research or on this career of studying carbons and soil carbon, how, if we are going into the forest to take the timbers out, if we're being heavy machines to extract the timbers out, how's that going to impact our soil carbon cycles? And, because I just want to know it's important for us to know. Even sometimes it's a hard pill to swallow. I just need to kind of understand. Is it going to completely destroy the whole cycle?
No. So the reason why I'm smiling here, if you're listening to this, the reason why I'm smiling is it's a hard question to answer.
Yeah.
Because everyone just, what's the impact? What's the result?
Yeah.
And it's like, well, it depends on your system. And the problem with any complicated system, and forests are ecosystems that are complicated, there's lots of different variables happening, means that you're not going to get a simple answer. So what is the impact of clear cutting in around Prince George versus the
coast?
Versus the coast,
yeah.
Right? They're all different. You can't manage them all the same because they're all in completely different ecosystems. Right. Different microclimates regulating different geochemical cycles. But let's go back to what you were talking about with source versus sink. What does that mean, right? So you're talking about something's a carbon source. It means carbon is coming from that. And this is what, I'm going to throw out a big word here, biogeochemistry, biogeochemical cycles. That just means the biology, the geology, and the chemistry mixed together to create these big global cycles. And carbon can move, and other elements do this too, it's not just carbon. The carbon can move from the air. It's taken up by the growing plant through photosynthesis. It's then fixed into that plant, becomes its biomass, right? That's where the tree comes from. It doesn't come from the soil, it comes from the air. So that's taken carbon from a atmospheric pool, the air, and put it into the biosphere. From there, that tree can then die, or it can have a leaf and it leaf falls to the soil, it's decomposed. That carbon is now in what we call the lysosphere. It's in the soil environment. And there it can get bound up for hundreds of years, even millennia, some studies show. So when we're talking about, well, what's a carbon source? We're looking for where this carbon is moving from pool to pool to pool. So our forests, the source, is the majority of the carbon coming from the forest, or is it being taken out of the atmosphere and it's landing in the forest as they start to grow? So is it a source and a sink? Well, of course, it's both at the same time. But what we're actually interested in is ultimately over the course of a whole year, where's the majority of carbon going? Is there a net movement from the atmosphere into the forest, or is it going somewhere else? So that's to just define your two terms first.
Yeah,
right?
I totally agree. And so, do you have an answer? Is it like a sink or source, or is it?
It's both.
It's
right.
Both.
So
yeah.
I mean, right. So, what is the impact? Just let's talk about first principles. You got a forest.
Yeah.
So what is the impact of cutting it down?
So we're taking the wood out.
Exactly. So what's happened to the wood? It's gone.
Yeah.
So the carbon has been released. Well, where is it gone now? Is it gone into furniture? Is it gone into a house?
So that's another interesting topic, is that I was reading some paper and then just hearing people talking about this is forest products, if you're using to build wood or build structure, build houses, you can use like dimensional lumber 2x4s and build it, or we have, the laminated
engineered wood.
Yeah, engineered wood, the cross laminated timber. And then you can build buildings up to, I think, 9 stories tall. And all these are, in comparison to concrete, to steel, sounds like apparently they emit less carbon compared to concrete and steel. Yeah. So I think if we're thinking about using wood products to replace the concrete and steel, there probably is a good thing. It's a sink, isn't it? Because we're not burning them.
So that's a sink. But where I'm going with this is it's a life cycle assessment, right? So it's what is your end use of that. So if you're taking your wood and you're making furniture that's going to be around for hundreds of years, you're building a 9-story building. Hopefully, it's going to be there for a couple of hundred years, right? Well, we know some cultural wooden buildings around the world, they can be thousands of years old, made of wood, right? So
made of cedar,
yeah. And so that is locking the carbon away. The carbon is in a wood product, so it's still in like the biomass, and it's not going anywhere. So that's stored. Great. That's what we want.
Right.
Go back to your concrete. Concrete is one of the biggest CO2 emitters. We need to produce less concrete just based on the manufacturing purposes of it. So if you can use less concrete, more wood, okay, that seems reasonable. Let's go back to our forest. We just chopped it down. Now what does it look like?
It looks like a scar on the earth. It looks pretty bad, initially, but when we go back and plant those trees.
Well, hang on, we haven't planted them yet.
We haven't planted yet.
You've got this big open space. So it was a forest before, right? Was it old growth forest or was it a plantation? Now that I've added another variable to this equation. Yeah. Let's just assume it was a plantation for now.
Yeah.
So we've got this plantation, got these big old trees. What was the ground like before? Well, it was dark, it was moist, you had lots of needles there. Well, now you've removed all the trees. Now all of a sudden there's lots of sunlight on it. There's lots of heat coming from the sun. It gets hotter than it used to. What's in those needles? What's the microbial community?
Yeah.
So what are they doing? Well, they start turning over that carbon that maybe wasn't so easily broken down before. Well, now it's a little bit warmer for them, so they can turn it over, and they start breathing. Now, when we breathe, what do we release? Carbon dioxide, right?
Right.
Where's that carbon dioxide coming from? From us.
It's coming from... Oh, that goes back to 103.
It does.
Final. That goes down the reaction chain.
Well, you don't even have to go that complicated.
Okay.
Your food, right?
Yeah, right.
Yeah. So we are combustion engines. We take food, we chemically set it on fire, right? We chemically burn it, and it comes out as CO2 through our breath, right? Microbes are no different. Bacteria, fungi, start working on this material, this stored carbon that's just dead organic matter now, and they start turning it over and they respire it. And now we're talking about, well, where's that carbon in soil? And this is one of your main points you talked about. Yeah. How much carbon is there in soil?
Yeah, how much?
Right. So
really
in the
curious.
atmosphere, there's about 560 gigatons of carbon in the atmosphere. There's about 1,700 gigatons of carbon in soil alone. Right? So there is more carbon in soil than there is in the atmosphere.
Crazy.
Right?
Right.
Now, we just changed our little ecosystem. We had an ecosystem that had trees on it. It was contributing dead organic matter, downwoody debris all the time. Root exudates going into that soil.
Yeah.
Feeding the microbial community there, but at the same time creating lots of this organic matter that's not really decomposing. Go into any coniferous forest and you're going to see the litter layer quite deep, right? So that's stored carbon too. But once you change the environmental variables, you make things warmer, slightly less wet than they used to be. The microbes turn all that over and you lose a lot of carbon. You can lose 60 tons of carbon per hectare, right? And to replace that,
right?
Well, how long does that take? That's a guess that nobody really knows, right?
Well, it's also, if you're thinking about the size of the trees that existed and how old your trees were before you harvested them, that's usually, especially for primary forests, that's a reflection of the succession time frame of that ecosystem to sequester that much carbon in the soil, right? So it takes a long time to get those trees back to those sizes. Now, even in the interior, if we're talking about a rotation age of 90 years, and then what happens at that point, you cut them down and you start all over again.
Right. But I also heard not argument or like some opinions. I'm just reading stuff online and, that when trees become old, they store more carbon, but they lose their ability to grab the carbon from the atmosphere. You know what I mean?
Do they?
That's just what I read.
But they're still contributing to plant detritus inputs, and they're still covering the soil, creating the soil environment for sequestration rather than soil respiration and release into the atmosphere.
Right.
Yeah, totally. It depends on your tree species, doesn't it?
It does.
Right? So some tree species will start senescing at 60 years, 90 years. I mean, that's why rotational is about 90. That's your peak productivity of that tree, and you cut it down at peak economic yield.
Yeah.
But what about other trees? Well, we know lots of them live for much longer, and there's a lot of evidence to say that really big trees can put on per year as much carbon mass as a medium-sized tree is, right? So these old forests, there was a really it's quite an old idea that the ecosystem has a maximum amount of carbon it can store, and then it kind of just plateaus out. But that's not actually true. When we look at old growth forests, these big old trees that keep putting on carbon. As Erica was saying, they just constantly feeding that downwardy debris, the root exudates that goes into the soil. That soil has no upper limit of storage, right?
The other thing about removing those trees is that you basically destabilize slopes, destabilize soil environments. So what happens if you get a massive atmospheric river or an avalanche or something, some sort of disturbance like that, all of a sudden you lose your soil. Now all of a sudden you're building back from zero, or not zero, but close to in some cases.
Exactly. Good point. Erosion events, really, really important.
100%. Yeah, I started this question really, really broad, and I like, Michael, you're helping me to break this question, like peeling this onion like layer by layer, kind of goes down to like really pinpoint to some key points right here. And I just want to make a point that obviously I'm not trying to argue. I just want to try to bring up some of the discussions, and some of the, forestry is such a diverse. Yep. There are a whole bunch of different opinions comes in, and then as a forestry student, as soon as I started like trying to reach out and to get different opinions, and it's really exhausting thing to do, because you just hear voices from all sides with all different opinions, and it's sometimes hard to digest. And there's this thing is, okay, well, if we cut down the trees, okay, we're taking the carbon, we're emitting the carbon and whatnot, but forest fire is also emitting carbons. When you have a big forest fire, there is a 2023 are the worst fire seasons ever recorded in BC.
100 million tons of carbon into the atmosphere. Absolutely right. Wildfires. So you have to think of these as big ecosystems. So how do we manage them? Are our forests managed? Yes. What has our fire suppression been in BC for the past 100 years? Just right to put out all fires.
Yeah.
We're learning now that probably wasn't the best strategy. But how much carbon do we lose from forestry? Depends, right? Depends on your ecosystem. Yeah. But on average, global analyses are showing it's about 10 tons per hectare from the soil is what you lose from forestry practices. From talking about what we do, opening things up. There's nuance there, because not everything is a clear-cut selective harvesting, all sorts of different approaches. And within that, there's nuance. Depends on where you are. But what's wildfire doing? On average, 60 tons per hectare of carbon lost. And what's happening now is we're getting more extreme fires that's making that number even more. Before, the fires would come through, they'd be quite low intensity burns, so you get like a scorched landscape. Some of the trees would still be alive. A lot of the soil carbon would still be there. It'd burn like the upper layer, but then most of it's still okay. But now we're seeing really high intensity because of the amount of fuel on the landscape, and it is burning the top, the above ground biomass, so the trees, they're gone, and then it's burning the below ground biomass, the soil organic carbon. It's being emitted out. And we know that Canada, in its climate targets, does not include forest fire burn. And there's logic there, and the logic they have is, well, that's not anthropogenic, so that's not human caused. So if we're trying to mitigate climate change through human activities, we can really accurately measure that, and then we can reduce emissions from factories or cement production or whatever, right? But that's not reality, because the planet doesn't go, oh, well, this comes from the forest, and so therefore it doesn't matter, right? Life cycle analysis is really important. You go back and study the past 30 years of data in forest fires, and it turns out that we have emitted about 60 trillion tons of carbon per year from the forests, and only net primary productivity is around about 2 trillion tons. So forest fires are just decimating any carbon budget. So it's not a easy thing, right? You're talking about just forestry, and what about forest fires? Yeah, totally. What about forest fires, right? Yeah. What I want to get back to is these, like, we shouldn't view these comments people are coming up with as dissenting voices. They're not. They're asking pointed questions. What about forest fires? Well, let's look at that. Can we manage our forests better? How do we manage our forests better to make sure that when forest fires do rip through, we're not losing as much carbon?
Totally. And a couple of weeks ago, actually, I want to make a point of the forest fires. It's not an anthropogenic thing. I will argue that if you believe in climate change, then
Well, I don't believe in it. The data says it exists.
it's overwhelmingly evident that it's happening. I just don't know why people. I guess still people believe in flat Earth, so you can't argue with those people. You can just.
Well, no, right, but you have to be rational and willing to accept new evidence in light of new data, right?
Right.
Forest fires. Across the boreals, when I was speaking of those numbers, they're across the North America, so from Alaska across Canada, and 20% of those, it's estimated, are caused by humans, right? And so if you were to use the government's logic of not including this in the carbon budget because it's not human induced and there's nothing we can do about it, well, we manage those forests, we look after them, and 20% of them are caused by us. So I think that's a pretty big omission.
Yeah. I just want to make a point that the forest fire, even we don't touch it, like even it's not started by human, but because of climate change, it's drier, the drought.
Exactly.
It's
we
a problem.
cause climate change.
Yeah. Because we are suppressing fires, and then that fire is a natural player. It's an important player in the ecosystem that we're managing fire. So we're kind of altered like the function of the forest kind of to be resilient in terms of like severe forest fire, and then when the fire happens, it gets more severe, larger fire.
Exactly.
And so we are. I think it's a human thing. Like even it's not started by the human, but there's some human factor that plays in that fire intensity there. That's just the point I want to make.
Yeah.
But I just want to ask another question is, so in terms of soil carbon, can I understand the thicker the organic layer, the more carbon they will store? Or is there a correlation there?
Yeah, so there's two types of carbon, right?
Oh, right.
Well, there's not two types of carbon. There's one type of carbon. It's an element. It's carbon. There's two types of soil organic carbon, right? And we can define it as particulate organic carbon. So this is stuff that you can actually see. This plant debris. It can be highly turned over, so you can't really tell exactly what plant it's coming from, but it's kind of just there in the soil. That's the stuff that's going to be eaten by the microbes. That's the stuff that's going to burn really easy, just accumulated. But there's no upper limit that there can be of particular organic carbon in the soil. It's just going to keep building year after year after year after year. The other part we've got is the mineral associated. So this is the carbon that adsorbs. So add means sticks to the mineral rather than absorb, where it goes inside.
Right.
So it adsorbs to the minerals. There is a finite amount because there's only so many minerals available to accept those carbons. Once they're full, then it's maxed out on its mineral associated. Are our soils maxed out? It's unclear. We don't know. But if it's mineral associated, it means it's really hard for the microbes to get to. They can't easily eat it. They can't easily produce these enzymes. And there's evidence that carbon can be locked away for tens of years, decades, centuries, and even millennia. And so if you can maximize your mineral associated organic carbon, you can then store that away for potentially hundreds of years.
How do you maximize that then? How do you...
You got to make sure your forests are putting their carbon back into the ground. And this is kind of coming into forest management. So how do we manage our forests? It's complicated. What is the economic? What does somebody want? And this isn't just a forestry thing. This is agriculture.
Yeah.
It's about production,
right.
Yield.
Yeah.
We want maximum yield. The bigger the tree, the more wood it's got. Great. Same thing with wheat. The more grains we've got, the more head we've got. It's fine, right? It's great. So that though isn't what a plant has evolved to be, and we have done that by making the plants. We fertilize them. We increase their growth rate. We stress them out. They're not actually supposed to grow that big and tall. What are they doing? Well, if a plant is slightly not pushed to the max, it actually releases carbon through its roots. It's called root exudates. And so the idea here is if we kind of just dial it back a little bit, not a lot, right? I'm not saying like no fertilizer, but you just dial it back a little bit. And so the plant is not achieving maximum 100% possible yield, but is about, say, 80%. then it's going to put more carbon into the soil. It's just naturally what it does. When it's got unlimited nitrogen fertilizer, the carbon goes into biomass production. If we can get that carbon back into the ground, it does two things. One, you get mineral-associated organic carbons. You've got all these what we call root exudates coming out. Those root exudates aren't just for mineral-associated carbon. They're feeding the microbial community. The microbial community are turning that over. The more diverse your microbial community is, the more nutrients they're able to get. There's arbuscular mycorrhizae, ectomycorrhizae. These fungi have lived in association with plants for millions of years. They were the first roots that plants ever got. So they've been with plants from the beginning, before plants were plants as we know them today.
Mm-hmm.
These can get nitrogen from the ground. They can get phosphorus from small pockets, much better than any plant can do. And they feed it back. And in exchange, the plants feed them carbon. It's great. It's evolved for millions of years, hundreds of millions of years before humans even got here. And we've messed that up. Because what we've done is just said, if we dump all this fertilizer, we'll get maximum growth. And then what happens is the plants don't need those microbes anymore. So they don't feed them carbon anymore. And if they don't feed them carbon, they die. And soil diversity goes down. Nutrient cycling goes down. Soil health goes down. You've got really poor soils. You're just essentially trying to grow these poor trees in really stressed out environmental conditions.
Right.
And so dial it back a little bit. Let the plants waste, if you want to put it that way, some of the carbon from yield, put it back into the soil, but that stimulates the soil biological diversity, stores carbon in the soil, but in return increases soil health, more nitrogen, more phosphorus, which means you don't have to put as much fertilizer on. It's a win-win.
I was going to say, obviously you're very familiar with soil being one of the values of FERPA. It has been since the get-go. But most of the time, considering soil health during forest operations is, okay, is the soil well-drained, sandy soil, or is it clay soil? And is it high risk for erosion, high risk for compaction? And that determines when you harvest. So we default to those practices, but has there been a lot of progressive thought into maintaining soil health during forest harvesting practices? Probably not really.
Yeah, speaking of the harvesting method, so for those who don't know, that typically we found clay, any type of clay, and even on flat grounds, you typically want to harvest in the wintertime. It's just such a high compaction hazard that I've went back to walk past them. You just see the heavy machine, just two grooves, super deep, super thick. I have no idea how to get away with it, but that's just what clay mineral does. If you don't harvest in the wintertime, your machine just sink, and then when you sink, it destroy all the top's organic soil. Am I correct on that statement? Kind of thing.
You get compaction, and
yeah.
It's very hard for plants to grow in compacted soil and microbes to survive in compacted soil. Why? Because all your soil has to have spaces in it, right? It's called porosity, but the spaces allow for air to be there, they allow for water to be there, allow for life to be there. If you can squish that down, then there's not a lot of space for the life to be, and if there is life there, then there's not a lot of oxygen, and so therefore it's anaerobic life.
Yeah, and then those like clay soil, they typically really rich as well, really moist and rich. And then in the context of like the SBS Prince George area, they lots of like Devil's Club and older, and they're super productive. And then if you go in the summertime and then you compact all those, I'm not a silviculture forester, but I can just picture how the plant's going to grow. But there's another harvesting method is using the harvester process, or they use they call it stump site processing. Literally just you cut down the tree, you process the trees at the stump, and then leave all the needles and branches at the stump. And then when you do that, you kind of create a buffer between the machine. Well, first of all, the harvester is lighter than a fellow buncher. And then you have all those needles and branches on top of the soil. So you're not like have direct contact with them. So in my opinion, it's just better when you have those sensitive soil that you want to protect, that just use processor or use harvester for their system.
I've talked to you about the LTSP before, the long-term soil productivity trials, with the combination of organic matter removal and compaction degree. And the most impact is the first couple passes of machinery on the forest soil. So you want to, if you're going to use machinery on the soil, if there's no buffer there, if the ground's not frozen, you want to mitigate how much area you're actually driving over on the actual cut block or harvesting area, because the biggest impact will be immediately on your skid trail.
Yeah, totally. And for those sandy soil though, so for clay soil, we typically, when you see clay, you just recommend winter harvest, but you still see people harvesting in the summertime, and they complain about their machine getting stuck, and I wonder why. And for the sandy soil though, I work a lot in the ESSF area. They kind of on the letter moraine. They're like glacial deposit on the till, really coarse. There are lots of coarse frags. They have really, really thin organic layer to begin with. I had this argument with you in our forest policy class that forest harvesting is have a significant impact on the soil carbon cycles and whatnot, and I made a point just to kind of argue with you.
I don't remember it being an argument.
It's not an argument.
My memory.
It's just to bring up some different views, basically. So you made a point that I think that 20%. Can you just tell us one more time what about the 20%?
I lost in my study.
Yeah.
I lost 50% of my soil carbon after disturbance. So forest floor removal, mixing of topsoil, and just direct sun exposure. 50% lost in that soil versus an undisturbed soil profile.
That's quite a bit.
Yeah.
Half the carbon. So I made a point that if you harvesting on those blocks on the letter moraine, they're really, really thin, because if there's a correlation between the thickness of organic layer and the amount of carbon you store in that layer, the thinner the layer, right, the less carbon you're gonna, I guess, the less impact you're gonna have on the land in terms of like the carbon.
Yeah.
Right?
Absolutely. I mean, there's lots of studies that show this. If you have more carbon in your soil, you will lose more. I mean, it kind of like is self-evident.
Right?
Right? But so that comes back to, where do we harvest and what's the appropriate method for harvesting? And so you talk about, selective harvesting. Let's just do that because that seems better than clear cut.
Yeah.
But one of the biggest, in a global analysis, one of the biggest losses was in the Alps from selective harvesting, because they had so much organic carbon stored in those soils that no matter what they did, they were going to lose it.
Right.
Right. So it's like, when you're saying, well, how should we manage these soils, these forests, and what selective harvesting what harvesting practices should we use? The answer is, well, it depends. Depends where you are. What are you trying to do? If you've got a site that has very little organic matter because of the microclimatic conditions, it's just not going to accumulate there. You don't need to worry about it as much, right? Probably clear cut, it's probably fine, right? You're going to destroy other things in your soil, right? You're not going to have that biological life. So perhaps you want to be thinking about it more from, how do we maintain biological life, which is then going to support our forest that we're going to replant later on. So perhaps keeping, selected groups of trees, staying like 10 meters away from them so you don't crush all their roots, maintain that biological connection from the tree. Carbon's coming in through those root exudates, the microbial community's turning over. We know carbon moves really quickly from photosynthesis. So that's carbon that's just been produced from photosynthetic activity. And it can be into the bacteria and into predators of those bacteria within 72 hours, right? So that's a fast moving time frame. And if you can keep that, and you can keep that biological activity, and that little discussion you were just having there over soil conditions in your forest, you're just talking about the physical properties. There's no mention of biological activity. And so I think that's where we need to go, right? Yeah, you can, clay soils, do it in winter, great. But what is the biology here? And are we harvesting this cut block at the right time, right? Have we restored the biological function, or is it still way degraded? Have we even accumulated some of the carbon that was lost when it was first cut 80, 90 years ago?
I think if I remember the conversation that we have now, it was talking about, I think I said something along the lines of, if you have a low productivity environment in the first place and you cause disturbance to that soil that has impacts on the soil biological community, the physical chemical properties of that soil, you'll deplete the productivity more so, and it might be very difficult to regenerate the type of trees, the type of forest that you desire after that disturbance. So thinking about whether it's worth harvesting in those areas is, I think, maybe what we were talking about.
Yeah, that's exactly what we're talking about, because you said your study is on Haida, right? That's
it was in Hartley Bay.
Oh, Hartley Bay?
Yeah.
Where is that? It's
close.
Okay.
Yeah, north central coast area. So
yeah.
Very wet, hyper maritime.
Got it. And then I've a couple of friends, they actually do logging on Haida, whether you agree or not, but it's just happening. And I've heard stories, because Haida, they're quite steep sometimes. They're quite steep, and then this phenomenon is they literally have rock and no mineral soil and then organic soil, and have nothing. There's literally no ABC layer. There's like your organic and then your bedrock, and then so they're like going up and down the slopes, and then like once you start sliding, they're on the machines like fill up on tree, go all the way down to the bottom of the hill. I'm just like, ugh. Gives me chill.
Yeah.
So, but also tells like how much organic layer that they accumulated.
Mm-hmm.
That goes back to the story of those trees being the anchor for the soil, the humic layer that's there that supports the life, right? If it's humus on limestone bedrock and you remove those trees, what's going to happen in a very heavy rainfall event? You're going to get landslides.
Yeah, that's another topic I keep wanting to, this podcast, the reason I started this whole thing is not trying to push any agenda, like either completely protection of the forest or completely clear cut every single trees in the BC. It's about bringing professionals from different sides and come talk to us. But if there were one agenda I want to push using this podcast, is break that binary approach, either clear cut or complete protection. There's so many, as foresters, we have so many different tools that we can use. You went to Trent for your master, right?
Trent and Masters, yeah.
And I went to Fleming. I'm wearing the thing right now. At Fleming, at Southern or Central Ontario, they have so many different harvesting methods. They have shelter wood. They have single tree selection. You can argue what the definitions are, but simply, we just don't take all the trees out of the forest, and they can still make money. They have tree marking. They have a 200-page tree marking guide that goes in and tell you exactly what kind of trees to take. Basically, the idea is to take the worst trees out, but still leave some, wildlife trees and whatnot, some of the decaying with pathogens, but you take the worst trees out and then leave the best trees in the stand. And then kind of after times, you have this beautiful forest that you can come back and harvest till the end of the time, and then also maintain
that's sustainable, right?
Sustainable, because right now, in my opinion, this is purely my opinion. In BC, when we talking about or sustainable forestry, we're talking about the growth and yield. We're talking about having something just like purely emphasizing the timber value, and then come up with, okay, we really care about the timber value. What else we can do to make sure the timber value is being protected? But the focus is on that. But if you read the tree marking guidebook, the emphasis is, I'm not saying timber value is not important, but they also, like the emphasis on the outer value also get elevated. You have to save so many trees. You have to walk around the trees and then, save the wildlife trees, all those cavity trees and whatnot. And I just think if there's one agenda I want to push using this podcast, or I have a YouTube channel, is diversify our harvesting method up here in northern BC. It literally we don't have to clear cut everything, but we don't have to. Maybe some area we should completely protect it, like there's no harvesting whatsoever. But we should also allow some degrees of management happening. Not clear cut.
Yeah, of course. I mean, like, fundamentally, we need wood products.
Yeah.
Right? And it's just, I've never viewed forestry as any different from agriculture. It's just done on a different time scale, right?
Yeah.
It's exactly the same. But it's done on a generational time scale. And that's one of the problems we have with forestry is agriculture, yield every single year. With forestry, we've setting up, like you mentioned the LTSP trials. Well, they're 30 years old now. Well, that's only 30 years in a forestry trial, right? Like you've
It's
got
like
another
baby phase.
80 years before it's even harvestable. So you're talking like 2 generations at least before you actually see the results, possibly 3. So the time scale's different. I always think it's like, well, what is our purpose? Like, what do we actually want to achieve?
Right.
And you see it in every management scenario of people degrading soils all around the world, not just in forestry, because we just want yield, we just want economic growth, and we know in ecology you can't have continuous growth indefinitely.
No.
Right? There's a carrying capacity here. That's just ecology 101.
Yeah.
And we have to remember that. But we have to remember that, like, economists don't remember that, right? You listen to anything from the government. So
Great point. So, I just keep telling myself I need to keep asking the questions is what can we do if we are chasing the timber value? In the meantime, what can we do better to manage whatever value that people care about, the ecotourism, the carbon, whatever the thing they're studying that they care about. So they, when you're mentioning about harvesting in those super organic-y, steep coastal area, it's very easy to say, well, we should stop logging completely in those areas. But, it's, I just think when we were waving the flag of stop this, stop that, and then we ban this and ban that in the meantime, can we do something? Alternatively, we can still go in and take some of the wood products out. But also, back to the balancing act. Everybody's losing a little bit because that's balancing, in my opinion. Like nobody's winning fully. I don't know.
There's that idea of zoning, right? That we have areas that we don't touch, areas that we harvest, and there's a third zone. I can't remember what it is, but it's this idea of, and I think that's what it should be, right? Like, get your prime areas, the areas that are unique, and we don't have a lot of these left in the world, right?
Yeah.
Rare biodiversity hotspots. That's where your species are going to migrate out of eventually and repopulate. So have those, protect those, literally put a fence around them, metaphorical fence, and don't touch it. And they're huge carbon stores, right? And we know that, like Erica was saying, if you take prime forest, which a lot of the forestry activity is still done on, where it's dwindling every year. I think, 20% right now we've got left in the province.
Old growth?
Possibly less.
Yeah, I don't know. I was just looking at some figures before I came, and
the provincial website says 20%, but there's the old growth strategic review. If you consider the site index, they have a site index 20. So that's like at the 50 years, your tree is going to be 20 meters tall. Your site index 20 to 25, they consider big tree old growth. 1% left.
1%.
Over 25 site index is 0.1% left provincial wise.
Right. So I mean, that's just telling you something right now. Should we just destroy that? Right? Like, no. Like, just common sense, surely, if there is such a thing, says, well, let's protect that bit because that's what is just left. But everything else, why can't we sustainably manage it, right? And what happens if you don't, right? We've been told that we can have sustainable management that's going to promote biodiversity, it's going to have maximum yields, it's going to have everything. You can't. We know that's impossible because you can't manage something for maximum biodiversity and at the same time have maximum yield for economics. So that's impossible. So we were sold an impossible dream for the past, 50, 60 years in BC. But what do we want? Do we want to have forestry here or not? And if we keep going and cutting down all the trees, eventually there's going to be nothing left, right? And then you're planting those trees on degraded soil with no biological life. They're not going to give you the yields And how do we know that right now? My understanding is it's all based on yield growth. They're still not measuring the soil biology. So you can not have anything, fertilize it, keep fertilizing it, you still get those yields based on 20, 30 years of growth. Yeah, it's kind of looking at what our charts say. Great. What about 60 years, 80 years? We just don't know. And what we do know in soil science is if you kill the biology, you destroy your nutrient cycles, you destroy what you're trying to do. You're trying to grow these trees, right? So you need to look after the soil health.
We also have a really poor idea of what our second growth timber looks like.
Right.
If, what is harvested is on the coast, well, you can't extrapolate that data to interior BC. And that's a lot of area that's been harvested over the past 90 years. That's a lot of oopsie if we figure out that we've been doing the wrong thing the whole time.
Yep.
Yeah, totally. And I just, we're just been using this European model. I keep mentioning this. We think we should replace the forest. The managed forest is better forest. Mm-hmm. This idea. I think in some cases it might be true. We had a Liam from Freer Logging came here to talk about how many more trees we have compared to before. We used to have this creature like a mammoth, I think.
Mastodon.
That's what it is. That eats the spruce. It was a niche that they filled to eat the spruce trees to keep the spruce trees low on the landscape, and then now the human killed them all basically, and then so that niche is gone and nobody's filling that niche. So we just let the forest grow, and it was suppressing fire. So and you heard this term. I don't know if people agree with this. We have a tree pandemic, meaning you have more trees than ever before, and then people always bring up the Jasper. Can Jasper fire be prevented if we do some management in the park? It's hard to say.
I think you've kind of got back to it though, is we need data. We need to understand these ecosystems properly. How did they function? How have they evolved? Right? And just go back to, okay, so you need to selectively trim them, right? This isn't new stuff. This is just basic population ecology. Right, going back 20, 30 years about how you have sustainable harvest of fish or moose or anything.
Yeah.
Apply it to trees, right? It's
a
bit beyond my area of expertise, but there's got to be a number that you can take every year without affecting the wider population and therefore the landscape ecology.
Yeah.
Take that many.
Yeah, totally. There's just photos showing, quite a bit of photos showing, I think I saved on my laptop that the photo was taken back in the 1920, 30-ish versus right now. You can see way more trees, and the trees gain elevation, and they up the hills now versus there's just bare ground back in 1920s, I guess. So they're just back.
So why was that? Were they harvested already, or were they just never there in the first place?
I think that photo that I'm thinking about that was when the First Nation was allowed to do prescribed burning. Mm-hmm. They're allowed to allow some low intensive fire.
I think the other thing too is if we're continually harvesting areas at 90 years, we're never really getting to that point where we're having the micro disturbance, canopy gaps, natural stand thinning that would have happened in the past, because we're just planting high density, removing high density.
Yeah, really good. You're not getting that age succession.
Yeah,
right?
We're not getting the natural age progression to that point.
Yeah, that's a really, really good point. Sometimes I think about this stuff, I just lose sleep at night. I keep I love talking with Roy about stuff like this. I go to his office, sit down, and just talk about stuff like that. If there's one thing I gain from coming back to school is I'm a mature student. I'm like 33 years old, believe it or not.
Oh, yeah, ancient.
Yeah. Oh.
I'm a mature student, too.
You look just fine. You look fine, too.
Thank you.
But I'm really I just gained this passion about I start being curious about things again.
Mm-hmm.
And I share with my buddy Ryan that when I was taking biology and chemistry the first year, it was painful. I had a really clear goal of coming back to be RPF initially. Now I want to be RP Bio too, but this biology, this intro level biology and chemistry and the calculus and all those things really push my boundary, and it makes me just be curious about things. And now I'm really curious about how we can do a better job while we're extracting timber from the forest. And that just the biggest, I think, the benefit of coming back to school as a mature student, because at some point, working in the forestry industry, I've become really tunnel visioned, and every tree's become a dollar sign to me. I just care about the piece size, the volume, how much we can get from here. And
I think that's super important, though, is to continue to have questions and be curious about things. Obviously, speaking for myself and probably you as well, I studied forestry because I love the forest, and that love is also a lot of curiosity. So making sure that you stay curious will help you make decisions that are 1% better or similar, hopefully, over the course of your career. And that's a start.
It is. If everybody from forestry degrees can go out and then just bring a little bit positivity to the community, I think we're doing a good job. And I don't know.
Well, alternative thinking too, right? Like adaptation, survival of the fittest, right? It's about adaptability. Those that can adapt survive, right? And if you just this is the way we've always done it. This is the way we've done it for 90 years. You're not going to survive in the future, right? The climate today is not the climate we had 100 years ago. Whether you're talking economic climate or actual climate, right? They're not the same. And so we have to adapt. We have to change. We don't have another planet which we can keep going and harvesting. We've run out of natural resources. We've run out. You just told me it's like 0.1% of really old growth, pristine forest left. So we've run out of it. It's gone. Well, what are we going to do going forward, right?
Yeah, it's funny that you mentioned that. Like you mentioned about you have to adapt. So I made a video about field camp, and then I made I kind of just, I put some of my thoughts in there myself, and I there's one quote I learned from 103 that I still remember till nowadays. Like, nothing in biology makes sense unless in the light of evolution.
That's right.
You have to think about evolution. You have to think about right now as a forestry community, we're facing a selection pressure that, you have to maintain the biodiversity. You have to maintain the ecosystem integrity. You have to make sure that our forest is, can face the challenge, whatever is coming, climate change, fire, insects, or droughts, whatever is coming. We want to make sure our forest can handle those. But in the meantime, we also need to maintain an industry that, because that just supports the community, especially I keep saying this, a lot of small indigenous communities up here kind of relying on forestry. That's just a fact. And so how do we do that? It's just really a hard thing. There are lots of selection pressure, and whoever can figure a way out to adapt, I just think they can start a business. They can just keep practicing forestry because they got things figured out. And then those who can't, then you're just in the history book, and then seeing other people passing down their legacies. And that just, so I always learn something from each course, even though I got a 48% from my first midterm. I don't know if you remember. It was my very first midterm I ever written in university. And at Fleming, I was straight A+ students. I was valedictorian, actually. I was doing really good. Not trying to say like Fleming education is not good, because I was away from school.
Fleming's a really good place.
Great place. Highly recommend. Shout out to all the Frosties out there. But I was away from school for like 4 or 5 years, and I came back.
You're just rusty, that's all.
Yeah, and they gave us a speech that, this is the first midterm is going to ever written, and it's going to be hard, the history or the average flow, and then it was true. And I failed it at 48%, and I started pretty darn hard for that thing. But I see myself, it's a wake-up call. It's a really humbling experience. I came here, I was a supervisor, a forestry supervisor before I came back, and then I was just full of myself, I'm the hot, the thing, and no, you're nobody. You're just like another student trying to.
The more you learn, the more you don't realize you don't know, right? And if anyone's giving anybody any simple answers on how to manage anything, right, let alone ecosystems, they're oversimplifying it. You just can't do it. My biggest thing for the management is, these forests did not evolve to be monocultures, right? These plants did not evolve in that scenario, so don't try and grow them in that way, especially because they're not just it's not wheat, right? You've got to have sustainability and have productive systems. Think about your sites. Each site is going to be different and require different management scenarios, right?
Yeah.
So
totally.
it's complicated is unfortunately the answer to a lot of problems.
It's complicated, but I just think we should not stop at the complicated part. We should
that's when to embrace it. Yeah.
Full on dive in, and then even hard, and then we just peel it like peeling an onion, like one layer at a time, and then, the more people doing this, the better. I'm not done with the questions yet. I don't know if you have
okay.
We got a studio book for 2 hours, and
right.
I have more questions.
Let's do this.
How about let's throw a question from Jason Fisher. Jason Fisher is a professor for the forestry policy. What's the class even actually called? I keep calling the forest policy.
I think it's just forest policy. Forest policy and management, something similar.
Yeah, he's amazing. Actually, he did the last podcast we recorded was with Jason Fisher and talking about forest policy and how policy is made, and then we talk about this buzzword, utilization in forest products, and which I want to talk about later. But he had a question for you.
Okay.
So he is interested in learning more about the impact of different harvesting system on soil carbon. If you maintain more canopy, do you maintain more soil carbon? Question mark. In some
circumstances, yes. In others, no.
Yeah.
Right.
So what circumstances is?
It depends. So it comes down to this. If you maintain the canopy, you are not completely changing the microclimate of the soil. So if you've got a soil in a forest, go through and you'll see hummock, hollow areas, you'll see lots of diversity. And then if you strip all that away, all of a sudden that's baking in the sun, and a lot of carbon will be released, right, through respiration. If it dries out completely and gets overheated, then the microbial community is not going to be able to do it, because if you're getting temperatures at the soil surface around about 50 degrees, which can be achieved in summertime,
right,
the microbes are going to shut down as well, right?
Right.
But if you can maintain that canopy, then you're not going to have that flush of microbial activity and just lose it through soil respiration, literally microbes breathing it out. So generally speaking, maintain your canopy. But there are studies that show in certain environments that it makes no difference, or it can have a negative effect, right? And so it comes down to site-specific locations.
I think it's worth mentioning because maybe it's not super obvious,
Sure.
but obviously when you're having a flush of carbon because of microbial activity, you're also having a flush of other nutrients that microbes are using.
Good
So
point.
you're also losing nitrogen and other nutrients like phosphorus that are really essential to plant growth, and oftentimes limiting, and then we spend money to actually fertilize and get those nutrients back into the soil. So.
Right. Because you did 5 years of consulting, right? I think I remember.
Yeah.
And then did you do some restoration kind of work using trees for mining
That was
sites?
my postdoc.
Postdoc?
Yeah. So that was going to Sudbury, Ontario. So for some generation of Canadians, Sudbury, Ontario was like hell on earth. Moonscape. You drove through it, you put your windows up, it smelled awful. And the reason for that is they're smelting nickel, and the smelters, there's a lot of sulfur in the rock that they're extracting the nickel from, and it rained down sulfur dioxide, essentially. And so it just killed an area, I think I calculated is about 4 times the size of Prince George, something like that. Just gone of vegetation. There's 1 or 2 grasses here or there. Massive soil erosion because there's no more trees. So they lost about 1 meter to 2 meters of soil gone from the landscape. And then
you mean like depth?
Yeah, depth.
2 meters?
Yeah. Globally, we are losing 1 meter every so many years. It's ridiculous how much soil we're losing across the planet, right?
Think about where that soil goes into rivers, into oceans, into places that shouldn't be.
I actually didn't know that.
It gets dumped.
That's
out.
wild.
And that's why soil health is so important. And like the UN said that, this is the decade of restoration, and we recommend that 2/3 of degraded land should be restored. And I think 1/3 or 2/3 of that land should be protected forever. Like, we need to rehabilitate the earth because we have just destroyed so much of the planet's ecosystems. We need those ecosystems. They provide vital ecosystem services for us. And so without them, we're going to be a challenged species, right? So let's restore some of those ecosystems. And so in Sudbury, I'm lucky that I was even part of this. These people were pioneering scientists back in the 60s and 70s and 80s who figured this stuff out, like how to even get it to grow. A lot of people said you couldn't get anything to grow in Sudbury. One of the things they had to do was remove the sulfur dioxide away in the first place. So they built a massive smokestack that they've now decommissioned, and it spread the sulfur dioxide far and wide, so polluted everywhere else, but in lesser levels. But it was really in partnership with industry, right? So industry paid for a lot of this with good government regulation, pushing industry, but industry going beyond that, cleaned up the whole area of Sudbury and did massive replanting efforts. And one of the things they find extraordinary is in Sudbury, if you want to chop down a tree, good luck to you, because people planted those trees, and that's my tree. I planted that tree. Yeah. Or if you're fishing or you're polluting in a lake for whatever, people restock those lakes with those fish. And so if they see you damaging it, it's mine. So there's community ownership in Sudbury that we don't see generally in society. A lot of people, like, okay, in Prince George, we've got nature on our back doorstep. There's a bit of a stronger connection here, but you go to like Vancouver, Toronto, any big metropolitan environment, people are disconnected from the environment, right? They don't think, that's just something there's us and then there's nature. Yeah. Right? And we need to break that. And I thought Sudbury was really, really good at having this community effort. Through restoration, when I got there, this is now after 40 years of tree growth, we were sat there and we thought, well, how much carbon have we actually accumulated on the landscape in 40 years? And it turns out it's as much as you would expect in these are red pine and jack pine forests, as a plantation in unpolluted areas. So it's great. So it showed that we could restore heavily degraded land to a plantation, but we are nowhere near biodiversity. There is no understory. Soil biology is really, really poor. We've got trees on the landscape is what we've got, but there's no anything else there. So that's like the next stage of restoration.
What was the planting species, out of curiosity?
The two species we planted?
Yeah, two species.
The jack pine, red pine.
Oh, red pine? Is it European red pine or is it domestic?
I think it's domestic.
Okay.
They chose those two species because they were hardy species that they knew could tolerate very acidic conditions. And now the planting strategy, like Sudbury plants many thousands, because there's still large areas that are still barren, and so they're still out there planting. And they've diversified. They're starting to plant deciduous trees in with it to get a more diversified forest. And come back to our forest management here in BC, perhaps we should be doing the same, because planting those deciduous trees, it raises the pH a little bit. You can get nitrogen fixes. You can get alder in there.
We have a very interesting view for deciduous forest, and then because in northern BC, when we talk about deciduous, we're basically talking about three species: the birch, the aspen, and the black cottonwood. Yeah. And for some reason that we don't use these wood. And then when I was in Ontario, we went to a casket manufacturer, like factory. They use aspen trees to build casket. And I've seen people building other stuff with aspen trees, and then for some reason we just don't do that. And then for the longest time, we need to clear, we either manual brushing or spraying to get rid of our competitions, aka those deciduous, aspen, the black cottonwoods, and birch. And I just don't know why. I hope somebody can give me an answer, like why in northern BC we don't use. I've laid out pure aspen block in Alberta. Apparently somebody using them for something.
I think maybe we just don't have the facility to process them because we're interested in making money off of our plantations. but it is definitely, I think there's maybe some pushback on the brushing now. Obviously, you were there at Eliza Lake this summer, and they rarely brush anything, and you walk through a cut block and everything is browsed by moose.
Yeah.
So.
Yeah, I just wondered, why? Because somebody else is using those somehow. Why we don't use them? Because we can, if we consider a cut block as a crop, as a crop field, it's our crop species. Then all of a sudden now you're taking care of it instead of just getting rid of them, because we know that how much important those deciduous species are for biodiversity. You know, that's a whole another podcast or like video that I'm working on, and really want to dive deep. But
it's a good nutrient input as well, because you're guaranteed to have leaf deposit every year, and conifer needles are typically acidic and don't degrade as well. So having those leafy tree inputs is really good for sort of getting some organic matter accumulation going on again.
And I read some paper, I don't remember too much detail, but just by leaving deciduous forest, you're actually keeping those underground mycorrhizae fungal network active, even post-harvest. So now you have all these network available for you when you're planting your trees. Now they just another roots. Now they're all connected again.
Yeah.
Well, you need to feed them. You need to feed them to keep them alive.
Yeah.
Yeah. And there's this idea. I mean, it's quite controversial with the whole mother tree thing. I mean, it's been shown that there's some story there with Douglas fir, but maybe not as quite as common as we think it is across the world. But think about it from the fungus's point of view. So we often think as humans about the plants and the trees' point of view, because we can see them. But the fungi is there, and if you've got alder coming through, aspen and birch and all these other species coming through, and it can tap into those while they're growing, it's surviving, and then eventually it's going to tap in to our pine trees and our spruce trees, and they can then feed off those. So from a fungus's point of view, it kind of wants both to be around, because eventually the carnivorous trees are going to outcompete the deciduous, right, in normal forest succession. So viewed from the lens of the fungi, that's the situation that it wants to be in. And so therefore those fungi are then helping your crop trees be better and be more healthy. But if you fertilize everything, if you kill off these deciduous, those fungi can't survive, and they're just not there.
There are some other couple questions here. I don't know if you can answer this. It's quite broad. So if Harry Potter shows up and hands you,
Have my one.
I actually learned that from you too. I'm pretty sure you're the first one that ever mentioned Harry Potter. I think it was, we were learning about either meiosis or mitosis, something about like if you wave the magic wand, you can just go into cells and see different things, how the things move, or, mitochondria and everything. So that I stole that. I actually used this Harry Potter thing in multiple places now. But anyway, so if Harry Potter shows up and hands you his magic wand, and he goes, you can wave this wand, and all the foresters in BC are your minions again. They're like, if you want to, we go to the moon, and they would go to the moon. And then, what would be the first move for first couple moves, or the first couple moves that to manage BC forests better for carbon? I know it's a big topic, but what would be the first move in your mind to do?
Well, I think it let's be clear, I'm not a forester.
No.
Right?
Yeah, but
I'm
just from
but I'm an ecologist, right? And trying to figure out how do you have a sustainable, healthy ecosystem? That's ultimately my goal.
Yeah.
Right? And so for that, I study the soil. And I think nobody values the soil. No landscape conservation, anybody, forest manager, whoever, is valuing the stuff that the plants grow in. And it's just completely, because soil is dirt, muck, right? Get rid of it. I don't want to be.
I think that's one of the reasons why I love it, though, is, think about everything that you love about a forest, the beautiful trees, the beautiful plants, the animals that live there. What would it look like if you took away the soil?
That's true.
Exactly. Like over 50% of the species on this planet live in the soil, right? Most bacteria, most fungi. There's a whole range of different species that feed on those. I would say, just if I could ask anything of anybody, any forest manager or anybody, is be open-minded. Look at what the data shows you, not what you gut feeling is or your economic outlook looks. What does the data show that we need to have sustainable managed ecosystems? And it comes to the soil. If you have a healthy soil, you're going to have healthy ecosystems. And how do you have healthy soil? Well, you can't just clear cut everything all the time. It's just not going to work, right? You got to, you got to maintain some trees behind to maintain that. That goes back to the age classification, right? Age succession. So these older trees, they hold on to those mycorrhizal fungi, now arbuscular mycorrhizae, depends on the species, and they're like reseeding it. And on a landscape perspective, you need your refugia, your areas that are protected, because the species can then leave there and migrate out. It's exactly what happened in the Ice Age, right? Not 10,000 years ago, we were under a kilometer of ice or whatever.
Yeah.
Right. There was not everything was. There was refugia, pockets that these species could live in, and then as soon as the ice went away, they spread out again. Well, we need to do that on the landscape. And so if you think about it in those terms, you're going to be more productive. You're going to have better management. But if you're just thinking about yield and dollars, in 10, 20, 30 years, you're going to have neither of those things, because it's going to collapse, right? And this isn't coming from me. This is coming from the literature.
Yeah.
They predicted the collapse we're in right now 20, 30 years ago, right? It's just, this is what happens when you don't manage ecosystems.
So increasing awareness probably of the soil, like increased awareness of forest soil, the importance of forest soils, and then
it trickles down. It trickles up. Well, it's actually a bottom-up effect, because if you start thinking about the soil and how I protect that, then you're starting thinking about, well, I've got to protect this tree to maintain the soil biodiversity, and I'm not going to harvest this again until the soil biodiversity has been replenished, right? And stop thinking about, oh, this forest is ready to be harvested because it's 80 years old or 90 years old and the timber's great, but if your biology isn't there, then it's not ready yet. And have that as a metric, and think differently, and ask questions. Why do we do it this way, right? Why, like you were saying, it's not just like, oh, this is Europe, and it's Europe, it's completely different from us, even though it's not really, right? But people are doing this in Ontario. And so why is BC so different from Ontario that we can't think differently and do things in a different manner, right?
I think Ontario forestry, that goes way back to the 1800s, between the wars between the French and the British, and I get Lacey Rose from I don't know if you know her, but she's the founder of the Women in Wood, and she's a really famous forester in central and southern Ontario, and kind of want to have her on the podcast and talk about the history of Ontario forestry, because it goes way back to 1800, where up here kind of started industrialized 1950-ish. That's just the number people throwing around. So there's a big difference. They have gone through the whole rotation cycle. They planted the red pine in the Ganaraska forest. You've probably seen those photos of the entire layers are gone. The roots kind of suspended in the air, and everything else is eroded, because it's really, it's like 90% sand, glacial deposit. But now they tried using red pine to restore those ecosystem, and now they're back to the success. The white pine's coming back, the deciduous mixed forest is coming back. We're still at the early phase of figuring things out. We still have lots of, they call it primary forest. There's debate about what that means, but literally just untouched forest by the industry that a lot of Ontario that just don't have. Everything is pretty much clear cut or removed. There's some protected area, but like most of the areas is removed because of the war. And so I think that just...
So can we learn things from them?
We can definitely learn things from them. But if you turn out, we keep that old thinking of, I share this story all the time, and this logger told me that, the forest is dying because he used to haul 100 loads a day. Now he hauls 10 loads a day, 15 on the good days, and he told me the forest is dying. If you're using back in the pine salvage era, that thinking and the thinking about the forestry nowadays, and of course it's dying.
Oh, it's not. Well, if you're going back to salvage, that's because there's an oversupply, right?
Yeah.
Like you just trying to get that for what it's all worth, right? That's not sustainable.
No.
Right.
And their debate about whether we should have done the salvage, whether we should have increased the AAC to that high, I think is a legit debate. And my question is, if we don't harvest those, the shelf time for pine, the number they throw around is 8 years. Meaning after 8 years, the pine just rot.
Mm-hmm.
They check, they rot, and then they're not economically feasible anymore.
Mm-hmm.
So what do? Do you leave them on the landscape? They just stand there? I guess it's important for biodiversity and everything. But we just turn on this, people call it timber pick perspective. You trying to maximize your timber value, then it doesn't make sense to do that. It makes sense to get them all out and just cash them out before they get rot. And
I think that the current slowdown may be bad economically, but it's not so bad for us to take a break and actually reconsider what the values we have are and how we can achieve them. I think it's a valuable time for everybody to reflect on what's actually important and what we're trying to do here.
Yeah, totally. For me, like I said, I used to think about volume in piece size, and I have a really clear idea of how much money the people can make under the current market. And I wouldn't want to say that's my specialty, but that's just what I used to do a lot. And then coming back to UNBC, obviously my views in forestry changed quite a bit. And so I just, if there's any message I want to send out, is just for those people, loggers or whatever you're listening, you need to kind of start change the old way of thinking. It's going to change whether you like it or not. You need to come up with a way to adapt and then make yourself more competitive in this kind of environment, instead of like fighting it, like trying to complain about it and just be actively prepare yourself to this kind of selection pressure. That's just what I want to say. That's purely my opinion, and I think we should allow this opinion to be spoken. Whether you agree or not, that's just my opinion.
Yeah. As long as your opinion's based in fact, right, and data,
yeah,
and not just I feel, right, then that's where it becomes meaningful, and you can have meaningful action. But it is more complicated. You're talking about economics. There is also the pressures of the government, people having jobs, revenue, all these things. But it will all collapse if you just keep cutting everything down, and then you just delaying it. You delaying the inevitable. And I think you're right. Like we're at this slow period now where you can reassess. And I think now's the time. Yeah,
and this slowdown is completely predicted when when we raised our AAC back in the early 2000s. This is completely predicted, and then it just happening where we're in this.
And people are shocked, right?
Yeah.
But it was predicted 20 years ago. It's like, 30 years ago.
Yeah, totally. Is there anything else you want to add for like soil carbon that you wish people would know, understand, that you wish all the forestry students, like one important message for all the forestry students to understand for soil carbon?
I think we've touched it. I think the fact that if anyone can come away from listening to this and think, oh, soils are important, I've achieved something, right? I think that's my number one mission in life, is just to make people more aware that if you deplete the soil, you cannot grow anything in it. And if you can't grow anything in it, the ecosystems die. And we require those, right? You can, and I what I also want to do is get away from just carbon budgeting and talking about it as just numbers, because it's not. And that's where we come across this like natural climate solution. And I've used that terminology before, and academically I use it if I'm just talking about carbon and I want to rehabilitate the landscape. That's a natural climate solution. So putting something that's an ecosystem, replanting trees, they're going to store carbon. Okay, great. But then there's nature-based solution, and it's just the same thing. There's a different lens of looking at it. So that's more bottom-up. If we maintain healthy soils, we put nice, healthy mixture, biodiverse communities, then we get biodiverse animals. We have natural nutrient cycling. We get more carbon stored. If you store more plants together, more species diversity, you get more carbon storage. Maximize your niches and not just have one niche occupied. And then that feeds up to healthy, sustainable forests that provide us with ecosystem services such as timber that we need, and also other benefits, hydrological cycling, clean air, actual wellness, like people spending time in the forest is a good thing. You're saying you love being in the forest, right? This is a really important thing. It makes us human and not just think about them as just, like you said, dollar signs.
Dollar signs.
Right. And then do all that, and lo and behold, you've sequestered all this carbon. Yeah. And you've got all these other benefits as well. And I think that's kind of like the philosophy I really want to look after.
Yeah, I totally agree. And then just one last time bringing back Ontario, that there is logging in Algonquin Park. Mm-hmm. I don't think a lot of people know that. I keep bringing them up. I want people to know in some places, not even in Europe, just our distant neighbor, we have logging and ecotourism coexist on the same land base. Why we can't do that in northern BC? We're talking about fire suppressions. Fuel management. We're talking about, there's a new term I learned recently. It's called pyro silviculture, using fire to manage silviculture. Why we don't do that? And there's just a lot to talk about, a lot to think, and then a lot for me to learn as well. And then how, when I joined the forestry, you have a big heart to do master. I thought about it. I'm like, nah, I can't. I need to roll in the trenches in the industry.
I think part of the reason why I would choose to do that is the thought of being a forester and making decisions that you have to make as a forester are decisions I don't really want to have to
it's difficult
make right now. And I'm still curious. I still have questions.
Yeah, out of everybody, you're 1,000% one of the smartest person I ever met.
Wow, you're flattering me now.
No, I mean that. And then you're really inspiring me, because we met at the I think Earth Science, right? Mm-hmm. That course, and I was like, wow, because I was your partner, and I was just like, whoa, I need to be smart and really do my part so I don't you don't have to carry me. But
I think you're showing some really great leadership skills in your commitment to your field of practice by doing this podcast, by getting people involved. You're demonstrating that you're willing to learn, and you're doing it in a professional setting versus academic.
Not many people read my work. Maybe if I flatter myself, I'll say hundreds of people have read my work, right? But doing this kind of stuff, this kind of knowledge translation, taking what we know from academia, taking what we know from academic partnerships with industry, right? Working together, taking that knowledge and disseminating it to people has so much value.
100% agree. If you care about old growth, the strategic review panel actually has a recommendation, which is somebody, I'm not saying I'm doing that, but somebody needs to convert those academia, like those really hard to understand, super hard read paper to something that average person, that 75-year-old John sitting in Tim Hortons in a Sunday morning can understand.
Yeah. And reach far, far more people.
But you're doing it right now. I've heard you bring up papers and case laws and other things that I've never read or I've never heard about. You do that on your own time, and you bring those questions and you ask them to people who know more or can sort of delve it out. And so you're bringing these things to people's attention.
I'm trying to. Yeah, I appreciate that. It means a lot to me. At least that's what I'm trying to do with all these podcasts and on the YouTube channel is make sure people from different backgrounds and perspectives, they communicate on the same frequency, because there's so many, like, they talk in different languages. The foresters probably emphasize the economic, and then the conservation activists, they emphasize the environmental, and they just never talk to each other, and they always talk around each other. They I call it the yes but conversation. Carbon's important, yes, but money is important, yes, but biodiversity is important, yes, but that just how we can make sure these different group of people, they actually communicate on the same frequency, and then to go somewhere, have some constructive outcome out of these talks. I guess that's what I'm trying to do with all these podcasts. And then there's another time I want to, if anybody listening to this that all of a sudden you have the desire, want to come talk to us for whatever the field you're studying, either you think every single tree in BC should be harvested, or you think not a single tree in BC should be logged. I don't care. I want to listen to you, and I think more students and professionals should listen to you as well. So please come talk to us. And we're just a whole bunch of students that are really curious about things and wanted to learn more. And that's it. This is not sponsored by anybody. It's not propaganda for anything. Like I said, there's no agenda to push. We just want to talk to the professionals and learn something about it. And I think I learned a lot today.
Good.
And soil is one thing that I didn't pay attention when I was in school doing that. And then when I was working, I was like, oh shoot, I should have paid way more attention, because it's it's a fundamental factor if you think about it back. Anyway, that's not a topic.
UNBC has a soil science program.
You have a club about that, right?
I do, yeah. So we're working on it. We're starting. We founded the club, the chapter of the club.
What is it called?
It's the UNBC student chapter of the PRSSS, so the larger organization, the Pacific Regional Soil Science Society. And we're just trying to bring people together. Even if you're not interested in soil science and you just want to get together and talk about some things with people. The dirty talk? Yeah. We will hopefully advertise a little bit more in the new year and try and recruit some new members, as well as continue to host events.
I just learned that C4 Radio, they actually can promote your thing for free.
Oh, really?
If you talk to them, they can probably just plug your things in their frequency.
Okay.
They offer, because UNBC Forestry Club, we run a Christmas tree farm. So they offer that to us, but we sold out all our trees this year, so next year. But it's something you can consider anyway.
Yeah, great. Good to know. Thanks for sharing.
No problem. Anyway, do you have any other question for Michael, or anything you want to add? Anything that we should talk? Otherwise, I'm just going to...
I think we've gone around everything.
Yeah, right on.
Yeah. I mean, there's always more to talk about. There's more detail, more nuance, but there's the gist of carbon.
Yeah.
In soils, in forests.
That's awesome. Yeah, I just really want to thank you, Michael. Thank you, Erica, to come. And I know you're really busy. You have a final
in a couple of hours.
You don't have a final, but your student's going to have a final,
they do.
Right?
Yeah, I'm fine. It's fine. I've taken all my exams.
And I also want to give a big shout out to the C4 radio station that, if you're watching on YouTube, all this professional setup, without all these things, this podcast won't happen. So I'm really, really grateful for C4 radio station for giving us this room to record. So this wraps up this episode of the podcast. We thank you for tuning in and spending time listening to us chit chat about forestry, nature, and life at UNBC. UNBC Forestry Club Podcast is a student-led podcast sponsored by absolutely nobody but a bunch of students who are passionate about forestry, the outdoors, the adventure. New episode drop, emphasis on hopefully every week. So stay tuned for more insightful conversations and inspiring stories. Until next time, let's continue to grow together, rooted in our love for the forest. Have a great week, and we'll see you in the next one. Thanks, Michael. Thanks, Erica. Appreciate it.
Thank you.